Okay, well, we're just going to take a few minutes to talk about recognizing visual patterns. It's something that you already do, and we're going to just apply this to more discussion on recognizing functions and patterns of functions. Okay, so I'll just give you a quick example of what you're going to see. We're going to usually use squares or rectangles, but we're going to draw something like this. And then we're going to call this figure 1. And then if figure 2 has 3 of them, what does figure 3 have? So you'd ask yourself, well, this figure 1 right there has 2. So it has 1 more than the figure number. Figure 2 also has 1 more than the figure number, so that gives us 3. So figure 3 must have then 1 more than the figure number, right? So figure 3 then would have how many? 1, 2, 3, 4. Now another thing to be aware of is how they are aligned. We could have set up the visual patterns this way as well. And that's going to be important because we're going to have to describe how they are arranged. Okay, so let's take a look at lesson 1, 2. All right, so we have our unit 1, lesson 2, right there. And you have your directions right there. So for each exercise below, draw the next figure in the sequence, determine the value, which is also called the number of tiles, for the next 3 figures, and then describe what the 10th figure looks like. And you want to keep in mind when you're describing that, that you write it in such a way that if you told somebody, they would be able to then draw that figure. Okay? So let's look at this first class example right there. Figure 1 has 3, and notice the shape. And figure 2 has 4. Figure 3 has 5. So when I look at figure 4 and I go to extend this pattern, I notice that there's always 1 there at the bottom, right? And then it gets a little bit, the add 1 right here each time. You see these pieces? So I'm going to draw my 2, right? And then this is figure 4. So those 3 match up with the figure number. Those 2 match up with the figure number. So figure 4, I'm going to put 4 squares up there. 1, 2, 3, 4. And I know, sorry, they're not perfect. But we have then, let's see, 1, 2, 3, 4, 5, 6. 6 is our value. So you could look at this also and say figure 1 has 3, figure 2 has 4, figure 3 has 5, figure 4 has 6. So I'm adding 2 to the figure number each time. So figure 5 then has 7, and figure 6 has 8. So when you're describing what these figures look like in words, it's important that you use the word row and column when they apply. A row goes, side to side, and a column goes up and down. So when I describe what the 10th figure would look like, well, it's going to have 12 tiles. We know that. 12 tiles with, let's see, 11 in a row and 1 in a row below. Something like that would probably do. It might not be the best answer, but it's a pretty good one. Guided practiced one. So you will have done this in class unless you're absent, so this will serve as a little review for you. Figure 1, what's the value? Meaning what's the number of tiles? 1, 2, 3, 4, 5, and 1 is 6. So yeah, figure 1 has a value of 6, and I'm seeing our pattern already. Figure 1 has a value of 6, so that's adding 5. So let's see if that works for figure 2. Figure 2 plus 5 is 7. Let's see. 1, 2, 3, 4, 5, 6, 7, right. There we go. So figure 3 must have 8, and figure 4 must have 9. So I'm going to draw it, though, because that's what it asks me to do here. Let's see. I notice that there's 1, 2, 3, 4, 5 going up. 1, 2, 3, 4, 5 going up. And then the number going across is the figure number, right? That gives us 9. So let's see here then. Figure 5 would have to have 10, and figure 6 would have to have 11. I'm going to let you do this on your own, okay? Describe it. Number 2, this presents a little bit of a different pattern. Look what's happening here. We have 3. Let me get my pen, sorry. We have 3, and then 3 and 3, and then 3 and 3 and 3. So it's almost like multiplication there, I think. Figure 1 has 3 of them. Figure 2 has 6, and figure 3 has 9. So I'm seeing a pattern here that you times the figure number, which is 1, times 3 to get the answer. So figure number times 3, so 2 times 3 is 6, and 3 times 3 is 9, so 4 times 3 is 12, and then if I had to draw it, I would do 4 columns, of 3. I have to erase one there. Okay. And then value of figure 5. Well, it's 5 times 3, so that's 15, and 6 times 3 is 18, and then I want you to describe that on your own. All right, I'm going to let you do this one here on your own, okay? And then we're going to kind of get into the essence of this lesson right here with what we are talking about as figure n. How do we extend this pattern to, the 1,000th figure or millionth figure based on our first few figures, right? So if we look at that, when we say the nth figure, we'll go back and read up top here. Now that you've discovered patterns, you're ready to express them in abstract terms using a variable. Keyword. A variable is something that changes or varies in a given situation. In algebra, a letter is used to represent a variable. We'll use n to represent the figure number in our tile examples. Look back at each guided practice example, and let's work together to determine the number of tiles in the nth figure. And this kind of goes back to what I was saying with if you had a figure number of 1, and you had 2 tiles, and you had a figure number 2 where you had 2 tiles, and a figure number of 3 where you had 3 tiles. Figure 4 is going to have, oops, wait a second, I have a little mistake here. 2, this one should have 3, and this one should have 4. So figure 4 then would have how many? And it would have 5 here because it's the figure number plus 1. The figure number plus 1. So where n is our figure number, we would say then that here the nth figure would have n plus 1. And then we could say, well, what does the figure 1 million, how many tiles does that have? It would have, you plug a million into the n plus 1, so we'd have 1,000,001. Okay, so I want you to practice a little bit of that on your own, and if you have some questions, let Mr. Cicero or I know. All right.